Flexibility in cooling systems is important to optimize energy efficiency. A cooling system must be designed to cope with the hottest day of the year and the highest occupancy of the space. But this doesn't mean it should run on full load every single day. When the outside temperature is lower, or there are fewer people inside, the system should be able to adapt and turn down. This flexibility includes variability in the compressor motor, fans, and refrigerant flow volume. Together, these elements ensure that the system only works as hard as it really needs to. The efficiency gains of flexible systems are reflected in efficiency metrics that account for seasonable variability, for instance the CSPF, the Cooling Seasonal Performance Factor, or the SEER, the Seasonal Energy Efficiency Ratio. These metrics measure the efficiency of the system across an entire season, therefore taking into account its performance at lower temperatures. Flexibility is also important when we consider the demand that air conditioning places on electricity systems, including at hours where peak electricity and cooling demand coincide. Thermal storage may be an effective way to reduce the demand on the electricity system at peak times, which are also the most expensive times to run the power system. Tanks of cold water or of ice can be produced at off-peak times, for example at night, which can then be used during the day in a chilled water distribution system. This way, the chillers have to produce much less during the day. This could also be a strategy to reduce the size of the chillers that you need in your building. Let's turn now to some of the technologies that enable flexibility of cooling systems. Thermal recovery by heat exchangers enables cool temperatures to remain in an air-conditioned building. This is extremely effective in a system where we must supply in fresh, outdoor air for the occupants, but we have to cool it first. The system works like this. Before entering the space, the fresh air, which is hot, is passed through a heat exchanger where it comes into contact with the cooled indoor air, which is being exhausted to outside. This way, the incoming air is pre-cooled and doesn't need to be cooled down just as much to meet the internal set point temperature. Similarly, enthalpy wheels are able to precondition humid air, transferring humidity across to exhaust air, lowering the load on the dehumidification system. Note that these heat exchanger systems can also be used in reverse, that is, to recover some of the heat from a heated space and transfer it to the cold incoming air, therefore reducing the heating load. Smart controls, which are able to switch systems on and off, or turn them up and down according to the varying load, can significantly reduce operational energy use, as well as increase comfort and ease of maintenance. Controls may be used to pre-cool a building, taking advantage of lower outside temperatures and low electricity prices, for example at night or in the early morning. Free cooling is possible when the outside air is cooler than inside, and the air is simply ventilated through the system at a higher volume and rate, avoiding the need to switch on the refrigerant cycle. It is also possible to shift the operations of the cooling system up or down in response to electricity prices or other signals. This includes adjusting the temperature set point, which is the temperature on your thermostat in your room, and taking other load-shifting measures such as turning the compressor and fans up or down. Smart controls can integrate more broadly into the building. For instance, they can be connected to lighting systems, shading devices, and blinds to ensure that all systems in the space are optimized to minimize overall energy use while ensuring occupant comfort. As you can see, there is a lot of complexity in the types of technologies that can be used, how they can be adapted to be more energy efficient throughout the year, and how they can interact to alleviate stress on electricity systems. One issue that we have not yet touched on, but that is fundamental to any discussion on cooling, is the role of refrigerant gases, which we will discuss later on in this course.